So the void is already named, it already has the proper name, but what he's trying to show is that the totality of mathematical being, right, of presentation as such, can be generated out of this one existential axiom, which is the void axiom.
The void, the power set of the void.
Well,
there's a bunch of NDA I think we should go through, but which I think is sort of the key of what he's doing, at least in this section.
yeah, well, I mean, let me go through this. So what we have, going back to it, is the power set. We have a void. Okay, so let's go with a set of all female presidents. What does that set include?
Not
No.
necessarily.
Yeah. So what we have is a void. Now here's the thing. We can also take the power set. Let's call this A, right? We can call it whatever, but it's still a void. We'll take the power set of it, right? So we're taking the power set of A. What do we get? Well, we get the void, right, because it's included in all sets, right? But then we also get a unique set, which is the set that is included. So that means as a set, right, this has to be a subset, right, a submultiple, a part. Well, here's the thing, a direct element, not a part, right, not a submultiple. So what we need is we need a subset. Well, that little subset is going to be a subset of the void. Actually, there we go. Wait, no, that's right. Sorry.
And this is just, again, simply because the void is in all sets, necessarily.
The void is in all sets, right? All necessarily.
Okay.
But by taking the power set, we've arrived at a new set, right? By the axiom extension, set of A and the power set of A are two different sets, which is demonstrable here because we have simultaneously the void and also we have the set of the void. This is what Badiou will later will call a singleton. Do you remember that?
I might have, I'm a little short.
It's okay.
But also, would you reiterate the axiom of extension?
Okay. The axiom of this extension is that a set is equal to another set if and only if they contain the same elements.
Okay.
Does that make sense?
Yeah.
But you'll notice, set of A
Includes the void, the power set of A.
includes the void and the set of the void. Right?
I mean, so again, this top one is the set of the void.
Right. This is the set of the void. All it includes is the void.
Okay. So that, yeah, again. And then the power set of A.
Includes the void, right? Because that's included in all sets.
Mm-hmm.
But then also, right, we're just putting a set around this set. Right? We're taking the set of the sets, power set. Does that make sense?
Probably one more. So again, we have set of voids, power set of A, which includes the void.
And that's it.
Because the void is also necessarily exists in all sets. And then, sorry, where is the actual generation of the? Because you have the set of nothing, which is included in the power set of A. And then where does the actual set of? Is it just the case that that's it? It's sort of this.
This is a power set.
Okay.
So what we have here, let's go back to our formula for the power set. Let's see.
So here's this gamma. If gamma belongs to beta, this implies that gamma belongs to alpha.
Yeah.
I actually write it so it's specific to what we're doing right now.
Okay. So. Oh. Element of alpha. And we'll just so what we have is we have two things going on here, right? We have the original void,
Okay.
which is just in the empty set.
And that's represented by the first part of the axiom of extension.
Yep.
Okay.
But then also, this void is going to be an element in the power set of A. So the power set of A, right, because all the elements of A are going to be also elements in the power set of A, right? So what happens is because this includes A, right, it includes the set of A, right? It includes everything that ends up in A.
Okay.
Does that make sense? Yes, no, so. Let me see if I can find something that's a little better for you. Okay, well, actually this is in the next section. Let's just get through the last little bit of this and hopefully it'll become clearer to you in the next section.
Let's try that.
So finally, what we have is we have this excess, right? This excess between inclusion and belonging, and this is at the bottom of 89. What he shows, right, is, let me just erase this stuff right here. Actually, let me erase this as well. So what we have is for all alpha, alpha is included in beta,
Why is that alpha belongs to beta?
and therefore alpha, yeah, belongs to beta.
This is on 89.
Okay, this is false,
Yeah.
right?
It sucks.
And it's definitionally false because it doesn't entail that any alpha or the inclusion of the alpha, which is included in beta, entails that alpha is an element of beta. So, for example, I had a really good
Well, can I just read that section?
Sure.
So it says the statement, which you just wrote on the board, is certainly false for any multiple beta, thereof, of excess. However, the inverse, which is to say you switch the belonging to, so it reads alpha belongs to beta, implies that alpha includes eta, or beta, can be true for certain multiples. It is particularly true for the set of nothing, the void, because its unique element, the void, is also one of its subsets, void being universally included. There is no paradox here, rather a singular property of the void.
Yeah, so basically what we've got going on here is that basically some sets that are included don't belong, and so, it's not true that if a set is included, it implies that it belongs. Okay, that's not true.
Right, write up the one that is correct.
Okay,
You just switch the signs.
so what is, and this is important, it's not true, it's possibly true, right? So does that distinction make sense?
Yeah, just
Okay, it's not for every set, it's not for every element, it's for some elements. And in this case, right, one of those elements is the void. So what we can have, so let's go to the Bunky Moon example. You'll notice I had to give a weird sort of contorted thing to have Bunky Moon make any sort of sense. Sorry, just 1 second. You have to have a weird contorted thing to have this make any sense, right? Like, for example, oh, Bunky Moon is included in the set of personnel, etc., right? But what you'll notice is it actually can make sense for things that actually are elements of the United Nations, right? It's hard to make Bunky Moon be included because he's simply an element, right? He's not included in the United Nations because he's not a multiple, or rather, he's not a part of the United Nations. He's an element. But here's where things get really easy. What about the United States? The United States is an element of the United Nations, but also it has a bunch of submultiples. So it is also a part of the United Nation, right? Because included in it is all of our peacekeeping forces, all of our legal ties, less so now, but the Geneva Conventions, right? So it's very easy in this case for an element to be understood as a part. Does that make sense?
Another way of stating that might be America belongs to the UN and it is also included in the UN.
Yes. That's
Or
Well, I
if,
think
actually, I guess to read it more formally, for all Americas,
yeah.
America belongs to the United Nations. If America belongs to the United Nations, then America is included in the United Nations, is the way that would be formally read.
Right, but again, what you should keep in mind, so
Well, I think that-
there's I'm gonna interject real quick.
Okay.
There's limits to these material examples, right? Because what we're not dealing with is a political situation as such.